Imagine a city with 1 million people, but no modern pipes or pumps. How did they get fresh water? This was the challenge for ancient Rome, and their solution was pure engineering genius. The Romans built massive structures called aqueducts, stone channels that stretched for miles across the landscape. They looked like long, high bridges, but their purpose was to carry water. These weren't just for show, they were the lifeline of the city. They brought in hundreds of millions of gallons of water every single day. Water supplied public baths, fountains, and even private homes of the wealthy. How did they manage this incredible feat without electricity or modern machines? The secret was a simple but powerful force: gravity. Roman engineers were masters of using the natural slope of the land. They found water sources in hills and mountains far away from the city. Then, they designed a channel with a very slight, continuous downward slope. This gentle gradient was crucial. If it was too steep, the water would flow too fast, eroding the channel. If it was too shallow, the water would stagnate. The ideal gradient was tiny, sometimes dropping only a few inches for every 100 feet of length. Finding and maintaining this precise angle over many miles was an incredible challenge. To achieve this, engineers used simple but effective tools. One was the chorobates, a long wooden plank with a water level carved into it. It worked like a giant spirit level, helping them ensure the ground was perfectly graded. Another tool was the groma, used for surveying and laying out right angles. This helped them plan the straightest possible routes for the aqueducts. But the path from the mountains to the city was rarely a straight, easy line. The Romans had to deal with hills, valleys, and all sorts of obstacles. When they encountered a large hill or mountain, they didn't always go around it. Instead, they often tunneled straight through the solid rock. These tunnels could be several miles long, all dug by hand with picks and chisels. Workers would dig from both ends of the mountain, hoping to meet in the middle. This required incredibly precise calculations. Sometimes they were off, and you can still see the corrective turns they had to make inside the tunnels. When the aqueduct had to cross a deep valley or river, the Romans built their famous, magnificent bridges. These arcades, with their repeating arches, are the image most of us have of Roman aqueducts. The arch was a key architectural innovation. It allowed them to build strong, tall structures using less material. The weight from above was distributed down the sides of the arch and into the supporting piers. This design was so effective that many of these bridges are still standing today, thousands of years later. The Ponte du Gard in France is a spectacular example, a triple-decker bridge that is both beautiful and functional. But here's a surprising fact. Most of the aqueduct system was not on high bridges. Over 80% of the total length was actually underground. The Romans preferred to build their water channels, known as conduits, in tunnels or trenches just below the surface. This had several advantages. Underground channels protected the water from contamination by dirt and leaves. They also kept the water cool and prevented evaporation during the hot summer months. Furthermore, building underground hid the water source from enemies. During a siege, a city's water supply is a major vulnerability. By keeping most of the system hidden, the Romans made it much harder for an enemy to cut off their water. The construction of these massive projects required a huge amount of labor and resources. Roman legions, skilled in engineering and construction, were often tasked with building them. The materials they used were built to last. They used stone, brick, and a special kind of waterproof concrete. This Roman concrete, or opus cementitium, was a revolutionary material. It was made from volcanic ash, lime, and small stones. When mixed with water, it created a mortar that could even set underwater. This made it incredibly durable and perfect for building bridges and channels that would be constantly exposed to water. Once the water reached the edge of Rome, it didn't just pour into the city. It was first collected in large distribution tanks called castella aquae. These tanks acted like modern water towers, holding the water and allowing sediment to settle out. From here, a complex network of lead pipes, called fistulae, carried the water to different parts of the city. The system was designed with a clear hierarchy. Public fountains, which provided water for the general population, received a continuous supply. They were the #1 priority. Next came the public baths, or thermae. These were huge social centers in Roman life, and they required enormous amounts of water to operate. Finally, if there was any surplus water, it would be piped to the private villas of the rich and powerful who could afford to pay a water tax. This shows that even in ancient Rome, access to private running water was a luxury. The number of aqueducts built is staggering. The city of Rome itself was eventually supplied by 11 major aqueducts, constructed over a period of 500 years. Together, they provided more water per person than many modern cities have today. This abundance of fresh water had a huge impact on Roman public health and sanitation. It allowed for the creation of an extensive sewer system, like the famous Cloaca Maxima. Flowing water from the aqueducts continuously flushed waste out of the city and into the Tiber River, helping to prevent the spread of disease. Maintaining this vast network was a full-time job. A special team of workers, the Aquarii, were responsible for constantly inspecting and repairing the channels. They would walk the lines, looking for leaks or blockages. Calcium carbonate from the hard water would build up inside the channels over time, a bit like limescale in a modern kettle. The Aquarii had to chip this away to keep the water flowing smoothly. Access shafts were built every 100 feet or so along the underground sections. This allowed workers to get into the tunnels for cleaning and repairs without having to dig up the whole channel. The Roman aqueduct system was a testament to their practical skills, their ambition, and their understanding of the natural world. They didn't have complex formulas or computers, but through observation, trial, and error, they created one of the greatest engineering marvels of the ancient world. When the Western Roman Empire fell, the knowledge of how to build and maintain these systems was largely lost. Many aqueducts fell into disrepair and stopped working. It wasn't until many centuries later, during the Renaissance, that engineers began to study the Roman ruins and rediscover their incredible techniques. The legacy of the Roman aqueducts is all around us, in the principles of modern civil engineering and water management. They set a standard for public works that continues to inspire us today. Thank you for watching. For more journeys into our amazing past, subscribe to Historical Repo.